This is an important thing to think about as you and I think about how AI is going to affect our world, that we're not necessarily going to be eliminated by AI. I hear that in the news a lot. People are worried that the machines are going to take all our jobs and we're all going to just become like the characters in Wall-E, and we just sit around in these little motorized wheelchairs and never do anything for ourselves again. And nothing could be further from the truth. Hey friends, and welcome back to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Now, before we go any further, make sure you're clicking the like, subscribe, notification bell, all the things to make sure you don't miss any upcoming episodes. This is the season finale for season 2. We'll be going on a little bit of a break here, and so when I come back, I don't want you to miss out. Make sure that you're following along so that you'll catch season 3 when it starts. All right, so today is our season finale for season 2. I am so excited to share this with you. We're doing AI integration. And of course, because it's 2024, everything has to be AI enabled. That's just the way we're doing things right now. The entire tech space is about products that have AI attached to them in some way or another. And that's all we've really heard about for the last year. So I thought it would be a fun way to cap off our series. To finish off a product that's already working fine. We can play the game, we can add and remove boards from the database, we can do all the things that it takes to play Hangman, but we don't have infinite replayability here. You have to keep adding boards to the list, and then they have to be randomly selected and all that. So I thought, what if we could have a language model generate those boards for us, and we could add those into our database. So we'll look at how to integrate that today and see, a practical use of an AI technology within the context of a game. So in order to AI enable our Hangman game, we're going to have to revisit a tool that we looked at first back in the end of season 1. And I'll make sure to link that episode here where you can follow along with that as well. Ollama is a tool that allows you to plug in large language models, and it serves up the model in a way that you can easily integrate with an application. But one thing I discovered in the last couple of months is that Ollama has released a Docker container for Ollama, so that the server can actually run within a container. And since we've had a heavy emphasis on containerizing the application this season, I thought that would be a fun thing to experiment with. Let's see if we can build an Ollama container, inject a model into it, and then use that as a back-end resource within our application. So architecturally, the way that we're going to think of Ollama is as the Mongo database. They sort of work in parallel if you think about it. Mongo has a data store, and it pulls in the data and responds to whatever queries when you ask for a board to be randomly generated, through the API. We're going to do the same thing with the Ollama container, in that we're going to send it the prompt, and it's going to send us back a board, and our API is going to assemble that into something that the rest of the application can use. So first, let's take a look at Ollama in its containerized format and what it is that we have to modify to make it work with our application. So here we are on the Docker Hub website. You can actually see the Ollama container is ready to go. It's sponsored open source software. It's actually been updated 5 days ago as of this recording, so that's really cool. It's actively being maintained and modified, and it's been used 5 million plus times. So it's getting some good traction in the community, and it seems like it's a valuable way to look at open source large language models. So how do we use this? Well, you can see it's a simple Docker pull command to get it onto our workstation. But by itself, what we're going to learn is that you still have to treat it like the normal Ollama server. That is, when you start it up, it doesn't have a language model attached to it. You're just starting up the Ollama server, and it's blank, and it's waiting for you. And I'll see if there's a command down here. Yeah, so you would have to enter the container manually and tell it to run whatever container, like whatever language model you wanted within the container. That's not going to be a tenable situation because when people start up our Hangman application, we don't want them entering the containers and making things happen manually. We want to automate that process. So what we'll do is come over here and let's look at the LLM section. And here's my Docker file. And so we can see the Ollama container is being pulled in. The next thing I do is make sure I'm running curl. Now we'll see why that's important in just a moment. But suffice to say, for the moment, you need to make sure that your container has curl installed so that you have the ability to use the curl command. Now, the next thing we're going to do in our container startup is we're going to grab our start model sh, which is a bash script that I've written here. And we'll look at that in a moment too. But we're going to copy that into our container. We're going to make it executable. We're going to expose the ports that are needed. And then we're going to start the container by running the script. Now this is an important step because the container by itself, like I said, isn't useful. It doesn't have a model installed. It doesn't have any way to actually interact with people. It's sort of an empty server that's waiting for us to add to it. So let's take a look at the startup script and see how it is that we actually get our container from being a generic Ollama container that can't do anything to ready to operate on the information we want to pass to it. So this is our start model sh. It's a simple bash script. Its purpose is to start up the Ollama server and pull a model into it. So the same things we would do if we were running it locally, in our normal workspace. We would have to do like Ollama pull llama 3 or whatever version we're going to use, right? So we have to do effectively those two commands. But there's going to be a little bit more to the script because we want to make sure that the Ollama server starts up before we start issuing commands against it. So that's what this whole section here is, the 12 through about 27. This is just a retry loop to validate with curl that Ollama has successfully started up. So if it responds on 11.434, then we know that our server's up and running and it's waiting for us to issue commands. If it's not, then we do the wait time and then we do a retry to see if we're going to get back into it. We're just making sure that the server is ready before we start using it. So assuming we get through that retry loop just fine, then we end up here. Ollama server is ready to go. Now, here's where we pull the model, but we don't want to pull the model every time because that's a really expensive operation. I don't know if you remember from the previous episode in season 1, but pulling a model is sometimes several gigs of data, and if you don't have the fastest internet connection, you could be waiting a while for this container to start up. So what we want to do is make sure that it's cached whenever possible. And if it is cached, then don't pull a new version, just use the one you already have. So we check the Ollama list command to see if llama 3.2 exists within the current setup. And if we have 3.2 already loaded, then we don't have to do anything. We can skip right over this. However, if we don't have it, then we've got to go do the Ollama pull command. And you can see that right here on line 33. We're going to go grab that. It's about a 2 gigabyte model. They vary in size, but generally speaking, you're talking about more than 1 gigabyte for most of the models. You could certainly experiment with one of the lighter weight versions if you wanted on a low bandwidth connection. At any rate, we're going to pull that, and once it's pulled, then the Ollama server is ready to go. It now has a model that you can throw data against, and it's actively listening on the correct port. So the last step in this startup script is to just put an infinite loop. And this seems a little weird, but this is because in a Docker container, if you don't do this, then you reach the end of the script and it stops. Your application quits and the container goes away because it says, hey, I finished the script. I must be done with my work. And so that's not how we want this to be. We want this to stay alive. So we put an infinite loop at the end with a sleep inside it. And the purpose of this is just to make sure that our container doesn't die after we've finished doing all the setup work. And this keeps the container alive so that it can listen on the port and respond as needed. So, little hint there, if you get stuck on that, I actually had to bang my head on that for a while because I didn't realize that my container was just going to die when the process ended. But this is the quick fix for that. I don't know if that's the best practice, so to speak, but it works, and so that's what we're going to use today. So that's all it takes to start up the language model container. So now we have an Ollama container that'll be running in our system. But we need to make sure that we've plugged it in to our Docker Compose. So you can see here is the LLM entry in the Docker Compose file. And we're going to build everything in ./LLM. And we're going to call it Ollama-container. And it will restart unless stopped. So this goes in conjunction with that infinite loop that the container will continue running until I manually tell it needs to stop. It can pull in the environment variables, which I'm not actually using, but that's probably an exercise that I should consider for the next round, is making sure that all of the variables that are being passed into the script go in through the environment instead of being hard-coded into the Docker file and such. So a little bit of didn't follow good practices of using the env, but it gets me by for this week's episode, right? So we expose the port we need, which is 11434, and we're going to add a volume. So this particular volume add is where our models are going to be stored. So we're pulling down Llama 3.2. It's going to be stored in that directory where it's now available for persistent cases. So if I stop the container and restart it, we should see in the startup script that we can skip the step of downloading the model because we already have it locally. All right. Anyway, back to where we're going next, right? So we now have an Ollama container that's ready to listen for requests. Just like with the database, though, we don't want to query it directly. We want to create an API that sits in front of it that gives us the ability to control how data is requested from it and make sure that things go in the proper format, and we don't have to keep repeating ourselves. So we're going to construct an API. It's sort of like the database API, but we're going to have an LLM API. And you can see the folder here. It's already ready to go. So let's take a look at what's inside it. This is a Flask app, and you can actually probably recognize most of this because this was almost a direct copy-paste out of the database API. Once I had copied everything over, I had to go back and change a few variables and a few things like that, and then write my route differently. So I'm using a get puzzle route instead of the ones that were in the database API. And I was also able to remove all of the database libraries because I'm not actually using them. This is using simple HTTP requests. So I can talk to the model over 11434 just using simple HTTP calls. And that's what I'm going to do from here on out. This is how we set it up. So my get puzzle endpoint, I have the prompt here, and I spent some time on my prompt to make sure that it was accurate in what it did. So you'll see that I tell it gets to pick from several categories, and it has to create a puzzle. And so what puzzle string should I use? I end with a question, and when I pass this in, it's going to respond with whatever it decides to answer my question with. So I'm going to grab that, and my full response, I'll go through some cleanup here because I don't want quotation marks or anything or extra white space around it. So I want to make sure that my data is as clean as possible, because what I'm getting back is the text that I expect to be the phrase that I push into Hangman. But there's another thing that's missing. I didn't ask it to tell me about what category it was using. And this was a thing that I ran into in my build and in my testing, that if I asked the model to do it all in one shot, it rarely gave me back exactly what I was hoping for. My first prompt was actually much longer than this, and it said you're required to respond in a JSON format that matches these criteria and has these fields in it. And every time the model came back with a slightly different version of that wasn't quite right. So I ended up finding out that I could be more accurate by breaking up the work into smaller chunks and asking it to focus on each of those things. That's part of how you tinker with a large language model. That sometimes you can give it too much in one shot and then it goes nuts and can't keep up with what you want to accomplish. But if you break it down into smaller tasks, just like with a person, right? If I give you a large, wide spanning product and say, I need you to build all of this thing with all of these features, it's overwhelming. But if I come back to you one episode at a time and say, hey, we're going to build Hangman today. Hey, we're going to build a Docker container to put our Hangman game in. Hey, we're going to build blah, 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 right? And so each step becomes a piece of the overall solution. This is an important thing to think about as you and I think about how AI is going to affect our world, that we're not necessarily going to be eliminated by AI. I hear that in the news a lot. People are worried that the machines are going to take all our jobs and we're all going to just become like the characters in Wall-E, and we just sit around in these little motorized wheelchairs and never do anything for ourselves again. And nothing could be further from the truth. AI is going to be a way to augment our skills rather than replace them. And so even though I can get the AI to do this for me, I still have to orchestrate it. I have to tell it what order I want things in. I have to think through what my final solution should look like and try to get myself to that state and work with the model to achieve that rather than just expecting it to do it all on my behalf. So I got it to give me the puzzle, and once I pull in the response there, I actually feed that back into the second thing where I say which of the possible categories is most relevant to the prompt you just gave me. So you gave me this puzzle string back. I want to take that and I want you to tell me what category that falls in. And so once I have those two bits of information, I now have the category, which we're calling hint. If you think of the earlier episodes in the series, we've used a hint to go along with the phrase in the database. And then we have phrase, which is the actual words that are going to be blanked out and you're going to have to guess the letters for. So I build the final response right here into a dictionary. And once I have those in a dictionary, I can use this JSONify method from Flask. JSONify gives me the ability to pass in the final response, and it's going to send it back as a JSON response. So now I get a properly formed object made from my dictionary, and I pass along the 200. And then, of course, I've got some error checking and stuff there. So that's my Hangman API for large language model. I now have a way to ask it to give me a puzzle, and it's going to respond with the two data points, the phrase and the hint, that I need in order to achieve like that. That's the object I need in order to build a new Hangman board. And just like with the other Flask API, I used a Docker file. Literally the only thing I changed in the Docker file to make this work was I changed the port from 5001 to 5002. So in the overall architecture of our Hangman app, the database API is running on port 5001, and the large language model API is running on 5002. Now I have both of those accessible to me where I can pull from either one as my app is running. So other than that, no real surprises. The requirements.txt is again very similar, but not exactly the same, mostly because I didn't have the Mongo things inside it. This is a language model API, so all it's going to do is use requests. It's not going to have a need for a database library that allows me to communicate with Mongo or something. So that's all it takes to build that out. And now if you think about it, we have a database, and we have a language model, and then we have an API on both of those that's accessible for our Python program to actually use. So what does it take to make our game run? Let's see. So we're going to use the game editor, and I want to take just a brief aside here to point something out to you. You'll notice there are a bunch of other modifications in my application. And this is because as I started testing this, I don't know why this happened, but for some reason, the front end application stopped working entirely, and I never really figured out why it was broken to begin with. But I had to make some major UI adjustments. So this week's branch is going to have all of those included in there, and what you get here should be like the final edition of the application. So it's a finalized version. This is as good as it's going to be for season 2. But what I'm putting up in this branch, I can guarantee I saw it work, and we'll do a brief demo here before we close up the episode. So keep that in mind, that there are some UI changes that we're not going to cover in the video, but they are definitely in the code. So make sure that you grab those and look at how things changed. It was a lot about learning how to make these windows operate together and pass data back and forth correctly. So really intriguing stuff, but not necessarily on topic for today. Just keep that in mind. Now, what we're going to do to incorporate AI is on the word editor. So I guess I called it the phrase editor, right? So on the phrase editor screen, we currently have 3 buttons. We have an add a new entry, and we have an edit, and we have a delete. And they sit underneath that tree view, right? So you've got the 3 buttons below the tree view, and then you use that to edit the database. What I'm going to do to make this easy to inject into the process is we're going to make a 4th button on that page. And the 4th button is going to be Generate with AI. And so the Generate with AI button is going to open the new phrase dialog box, the little pop-up, and it's going to automatically inject a suggestion into the fields. So it'll operate almost exactly the same as the new or edit pop-up dialogues, but in this case, it's going to populate it with data from this new LLM API that we created. So let's take a look at how this works. Oh, I almost forgot. We have an LLM API class that we're building into the application as well, into the front-end application, just like we did with the database API, where we had the DB integration handled here so that we just had simple methods to call, and we made it so there's a single place to connect to database stuff, so it's not spread out throughout our code. We're going to do the same thing with the language model API. And this one's even simpler because it really only has one thing to do. You instantiate the class, and it passes in a couple of constants, and then there's the one method. So it's going to go get the data, and it's going to respond, or it's going to grab the response and validate that it got a 200, and it's going to send you back the JSON for that entry so that the application can easily use a puzzle. Weird aside, sorry, it's how my brain works. But let's go back to the game editor and look now how to plug it in. So the first thing is we added our LLM API up here as an import, and we have the ability now to use that. All we have to do is instantiate it here. So we have an LLM variable that's going to instantiate the class. And then we're going to come down here where we were building the buttons, and we added a new button. So here's AI Generate Word. And for this button, it works the same as far as everything else. It's just like the other buttons. The only 2 differences are, of course, the title text and where it's going to appear on our grid. So I had 3 buttons on row 1, and the screen is 3 buttons wide, or 3 grid columns wide. So there was a 0, 1, and 2. And I wanted this one to appear on level 2 underneath the very first button, just so that I don't have to figure out how to rework the entire grid. It just it was quick and dirty and made better sense to me. So that's what I've done is I've added a new button on row 2 by itself on column 0. So it's the only button on the second row of the grid. But that's where we're going to put AI generate word. Now we'll slide down here to AI word pop-up, which is the thing that gets called when that button gets clicked. And this was really intriguing to me because one of the things that we did when we set this up is we reused this edit pop-up. So if you are doing a new entry, you want it to be blank. So you pass in no extra data. You don't put the word or the hint on it. And creating a new pop-up just goes. You can see that appear on add word pop-up. For AI, I want to grab the LLM puzzle. So I want to get the suggestion from the AI, and then I want to push that in as my data. So it works very much like editing an existing, except it doesn't actually exist. We're getting it from the language model first. So that's what we're doing here. We call the LLM and say, hey, give me the puzzle. And it puts that in the response. And now I know that the response should have a hint and a phrase. And so I grab those, put them in variables, and pass them into my edit pop-up. And then edit pop-up is just going to operate like it always does. It's going to take whatever comes in there and it's going to put those values into the text. So let's take a minute and see how this actually works. The first thing I have to do is come down here and we are going to do docker compose up -- build. And so this is going to run all of the containers behind the scenes, except I forgot to start up Docker Desktop. So let me go start up Docker Desktop, and that gets my daemon running. There we go. And you can actually see in my Docker Desktop, I have a ton of things that now show up, right? I have all these containers that live inside the s2e Hangman application. I have an LLM API, I have a Hangman API, I have a Mongo exporter one, I have a Mongo container, I have an Llama container, I have a Grafana, and I have a Prometheus. Those are all the things that make up our application other than the front end code, which doesn't run in a container. So what we're going to do, we'll go back here and I will reissue this command, docker compose up -- build, and we'll see all of those things start to happen. And it's working, it's working, it's working. And all of that, you see all the things scroll by, and we can see all of our containers are now showing green dots. They have all started up successfully. So now that I have that running, let's go over here. In this terminal, I'm going to issue python main.py. And here's our application. So we'll move it here to the center of the screen where you can see it easily. And it started up with a game and it says, hey, there's a programmer quote. So guess a letter. And let's see, what do programmers say? They say, I'm cheating because I know that my database only has a few entries in it. They say, hello world. And congratulations, I win the game. There's my entries. Okay, and then I can come up here and I can do a new game, and it picked another one. What's the best YouTube channel? Okay, but I don't feel like playing right now. What I want to do is go to the phrase editor. So if I go here, we can actually see the phrase editor started up. It has these things inside it already. And so we had these buttons that worked before. You do an add word and you would put in your new entry, or you would click on one and you do edit, and then you have the ability to change it. Or you could click on one and hit delete and it would go away. But what we've added is this AI generate word. Now, this is going to take just a second because the language model is a little slow to run. It's not real-time instantaneous feedback. It takes a second for it to process. But we can see it do its spinning thing. And in just a moment, we should have a pop-up that appears with our new phrase. And so it's decided that the phrase should be the beach is a perfect place to relax. And the hint is it's a place. And so now we have the ability to add in new things that are AI generated, just like that. And that, my friends, wraps up season 2 of the Adventures of Blink. I have to admit, I don't know how I'm going to top this in season three. Season two is probably the coolest thing that I've done. One part of it that's really exciting is being able to build things and see them work. But the other part is to be able to do it and share it with people and hopefully find that it either inspires them or informs them in some way, helps them to improve on what it is they like to do. And so I hope you're getting something out of this. I hope you're enjoying the experience, but I also hope that you're learning from it and that you're seeing things, techniques, or tools that make you stop and think and approach your work differently. I would love to hear your stories about that. And so maybe that's the assignment in the intervening period here between seasons two and three. Uh, Tell me a little bit about what you've been up to. Throw a note in the comments if you come across this video and go, oh, this is really good stuff. I'd love to hear what it is that you've learned from it or what you found appealing or interesting about it. And I would love, 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 love to see what you build. So please, by all means, share it with me. I look forward to seeing you around. We're going to be on a little bit of a break now. It's going to be a few months. We're entering the holiday season here, and I know that that's going to be full of excitement and distraction. I hope that you have a wonderful holiday season with lots of warmth and love in your life. And I can't wait to be back with you sometime in the new year. I would guess I'll probably make an announcement right around New Year's about the season three planning, and then I would expect season three to kick off in earnest probably sometime in February. So until then, friends, I can't wait to see what you build. I hope you take care, and we'll see you around.